Hello everyone, and welcome back to YLab. Today, we're looking at a simple glass of water. See the ice cube? It's floating. Why?
Everything heavy sinks in water, right? Rocks sink, metal sinks. Even massive ships would sink without special design. But somehow, solid water floats on liquid water. And if that didn't happen, life on Earth might not exist. So, what's really going on? At first glance, floating ice feels completely normal. You see it in drinks, frozen lakes, massive icebergs in the ocean. But scientifically, this behavior is very strange, because most materials follow a simple rule. When a liquid freezes into a solid, it becomes denser. Density is simply how tightly matter is packed. If something is denser than water, it sinks. If it's less dense, it floats. That's why rocks sink. That's why wood floats. And normally, when substances freeze, their molecules pack closer together, which makes the solid heavier for its size. So logically, ice should sink in water, but it doesn't, which means something very unusual is happening inside water itself. To understand the mystery, we need to zoom into the microscopic world. Water is made of tiny molecules called H2O. Each molecule contains 2 hydrogen atoms and 1 oxygen atom. These molecules stick together through a special attraction called hydrogen bonding. Think of hydrogen bonds like tiny invisible springs connecting molecules. In liquid water, these bonds constantly break and reform. The molecules are always moving, sliding, and bouncing around each other, which keeps them relatively close together. But when water cools to 0 degrees C, everything changes. The molecules slow down dramatically. Instead of moving randomly, they lock into a rigid structure, a beautiful crystal pattern. Each molecule connects with 4 others in a specific geometric shape. But here's where water breaks the rules. This crystal structure actually pushes molecules farther apart. Ice forms what scientists call a hexagonal crystal lattice. Imagine building a structure with perfect hexagons. The shape creates tiny empty spaces between molecules. Those spaces make ice expand. Instead of packing tightly, the molecules spread out, which means the same amount of water now takes up more volume. And when volume increases, density decreases. This unusual property is known as a density anomaly of water. And it's the reason ice floats. Ice is about 9% less dense than liquid water. That tiny difference makes a huge impact. It's why ice cubes float in drinks. Icebergs float in oceans. Frozen lakes have ice on the surface instead of the bottom. But here's where things get even more fascinating. Imagine if ice behaved like most solids and sank instead of floating. Every winter, lakes would freeze from the bottom up. Ice would sink. More ice would form and sink again. Eventually, entire lakes could freeze solid. Marine ecosystems might collapse. Life underwater would struggle to survive. But because ice floats, something amazing happens. The floating ice forms a protective layer on top of the water. That layer acts like an insulating blanket. It protects the liquid water below from freezing completely, which allows fish, plants, and microscopic organisms to survive winter. In other words, a tiny molecular quirk in water may have helped protect life on Earth for millions of years. Burst pipes, glaciers, floating icebergs. This strange property explains many things we see around us. Frozen pipes burst in winter. Glaciers slowly move across mountains. And massive icebergs float across the oceans. All because water expands when it freezes, something almost no other substance does. So, the next time you drop ice into a drink, remember this. That tiny floating cube represents one of the most important quirks in nature. A simple arrangement of 3 atoms that protects oceans, preserves ecosystems, and may have helped life survive on our planet. Sometimes, the smallest molecules shape the biggest stories on Earth. Before you watch this video, did you know ice was actually less dense than water? And what do you think Earth would look like if ice sank instead of floating? Let me know in the comments.